Okay, so the sum and difference identities. So these are the different sum and difference identities. We have sine A plus B, the sine A minus B, the cosine A plus B, the cosine A minus B, the tangent A plus B, and the tangent A minus B. Again, these are the different sum and difference identities. So we have this problem. So let cosine A that's equal to 3 over 5 and sine B that's equal to negative 5 over 13. Then where A is in quadrant 1 and B is in quadrant 3. Then find sine A plus B. This sine A plus B is equal to sine A times cosine B plus cosine A times the sine B. But from the given, we only have this cosine A and sine B. So we still need to find for sine A and cosine B. So to solve for this unknown, we're going to use this identity that sine squared plus this cosine squared is equal to 1. So again, this is the identity we're going to use to solve for the unknown. Now for sine A, so therefore our angle is A, so that's sine squared A plus cosine squared A, that's equal to 1. Then substitute now the value. So sine A is unknown, so we have sine squared A plus cosine A. Cosine A is 3 over 5. But we have this square, so therefore we need to square this 3 over 5. And that's equal to 1. Then you simplify, so sine squared A plus distribute this exponent to every number. So we have 3 squared, that's 9, and 5 squared, that's 25, and that's equal to 1. Then to solve for sine A, transpose this 9 over 25. So sine squared A equals 1, then minus 9 over 25. Now, when adding or subtracting fractions, so we need to find the LCD, or we can rewrite this 1 as 25 over 25 because the denominator is 25. Then we can solve now for the difference of these two fractions. So sine squared A is equal to 25 minus 9, that's 16, over, just copy the denominator. Then to solve for sine A, take the square root, cancel. So therefore, sine A is equal to positive and negative square root of 16, that's 4, square root of 25, that's 5. But we still need to find the sign of sine A. So we need to check if sine A is positive or sine A is negative. Then from the given, we have this A is in quadrant 1, and in quadrant 1, all function positive. So therefore, sine A is positive, 4 over 5. This is sine A. So we're done with sine A. So we still need to solve for cosine B. So our angle now is B. So the same formula. So sine squared B plus cosine squared B, that's equal to 1. Then sine B, that's a negative 5 over 13. Then we have this squared plus this cosine squared B, and that's equal to 1. Then simplify this one. So this negative 5 squared, that's 25 over 13 squared, that's 169. Then plus this cosine squared b equals 1. Then to solve for cosine b, so transpose. So we have now cosine squared b equals 1 minus 25 over 169. Then we can rewrite this one as 169 over 169 because the denominator is 169. So therefore, cosine squared b, so copy the denominator and 169 minus 25, it's 144. Then to solve for cosine b, take the square root. So cosine b now is equal to positive and negative. So square root of 144, that's 12. Square root of 169, that's 13. Then to solve for the sign of cosine b, now from the problem, b is in quadrant 3. So in quadrant 3, only tangent and cotangent positive. So therefore, this cosine b is negative 12 over 13. Again, only tangent and cotangent positive in quadrant 3. So we have now all the values. So we have sine A, cosine B, cosine A, and sine B. So we can solve now the value of sine A plus B. So substitute now the values. So sine A is 4 over 5. Then times cosine B. Cosine B is negative 12 over 13 plus cosine A. So cosine A, that's 3 over 5 times sine B. Sine B is negative 5 over 13. Then you simplify. So 4 times negative 12, that's negative 48 over 5 times 13, that's 65. Plus 3 times negative 5, that's negative 15 over 5 times 13, that's 65. Then you combine. Since the same denominator, just copy. So negative 48 plus negative 15, so the same negative, so you add. So we have 48 plus 15, that's negative 63. So this is now the value of sine A plus B. Then to solve for secant A minus B, now since cosine A minus B is equal to cosine A cosine B plus sine A sine B, and from an identity, the secant is equal to 1 over cosine, so therefore this secant A minus B is equal to 1 over cosine A cosine B plus sine A and sine B. So substitute now the values. So again, cosine A, that's 1 over 3 over 5 times cosine B, that's negative 12 over 13. Then plus sine A. Sine A is 4 over 5 times sine B. So sine B is that's negative 5 over 13. Then simplify. So this one is negative 36 over 65 plus this one is negative 20 over 65. Then simplify. So this 65 denominator. So negative 36 and negative 20, that's negative 56. Then get the reciprocal. So 1, that's negative 65 over 56. So the reciprocal of the denominator. So therefore, the final answer is negative 65 over 56. So this is for secant A minus B. Then to solve for tangent A plus B, so this is the formula. So we still need to find for tangent A and tangent B. So we're going to use this identity that tangent is equal to sine over cosine. So to solve for tangent A, and that's equal to sine A over cosine A. Then substitute the values. So sine A, that's 4 over 5 over cosine A, 3 over 5. Then get the reciprocal. So 4 over 5 times 5 over 3. So cancel 5. So we have now 4 over 3 for tangent A. And for tangent B, that's sine B over cosine B. So sine B, that's negative 5 over 13. And cosine B, that's negative 12 over 13. Then get the reciprocal. So negative 5 over 13 times negative 13 over 12. So cancel 13. And this negative divide by negative, it's positive 5 over 12. So this is for tangent B. Then to solve for tangent A plus B, so substitute now the values. So tangent A, that's 4 over 3, that's 4 over 3 plus tangent B, that's 5 over 12 over 1 minus 4 over 3 times 5 over 12. Then for the numerator, so LCD, that's 12. So 12 divided by 3, that's 4. Times 4, this one is 16. Plus 12 divided by 12, that's 1 times 5, this one is 5. Then 1 minus, then you simplify, so 4 times 5, that's 20. And 3 times 12, that's 36. Then 16 times 5, this one is 21 over 12 over this one, the same as 36 over 36 because the denominator is 36. Then 21 over 12 over, so 36 minus 20, 16 over 36. Then get the reciprocal. So we have now 21 over 12 times 36 over 16. Then reduce the fraction, or you can multiply easily, then reduce the answer. So let's try to reduce this one first. So 21 and 12 divisible by 3. So 21 divided by 3, this one is 7. And this 12 divided by 3, that's 4. And this 36 and 16 divisible by 4. So 36 divided by 4, this one is 9. And 16 divided by 4, this one is 4. Then multiply, so the final answer now, 63 over 16. So this is for tangent A plus B.